Hey, boys and girls, how's everyone doing today? We're going to do, I think, a simpler version of what we did yesterday with equivalent fractions. I have a couple examples up on the smartboard that I'm going to be kind of showing you in a second. Right? And again, here are my kind of three strategies or three questions I always want you to ask when you're working on these. First question or first step you're always going to think about is what fraction do we start with? For instance, over here, I have one shaded in out of four, 1/4. Over here, right, I see two shaded in out of five, 2/5. Over here, I see five shaded in out of six, 5/6. That's step one. You're always just thinking, like, what was my original fraction? Right, this one I haven't changed yet. These two I did, and I'll get to that in a minute. Okay, but just again, you're just starting with kind of what is my original fraction? What is kind of already there? As I just said, this one starts off as 1/4. There's one piece out of the four it takes to make a whole. Step two, again, in this one, I was gonna keep it simple. These are the ones that kids usually have the easiest time with when they say, basically double it or chop each piece in half. You have to do it to kind of each piece. Some of my students yesterday were just cutting that blue one in half, where it was gray on your assignment yesterday. Right? You have to do the same thing to every single piece. I'm going to show you kind of going up and down. The other ones go the other way. And you notice all four pieces got chopped in half. One thing I talk about a lot with my students is this, right? How much I had didn't change. It's still that blue amount. That blue amount has not gotten any bigger or smaller. The actual part I scribbled in. Right? All that's changed is how much each box is now. Again, this is kind of probably the newer or the harder part in the middle. How did I change each piece? Each piece got multiplied by 2. That's kind of that middle, that's number 2. How did each box or piece change? They all have to change the same. Like I can't cut this one into 3 pieces and then cut this one over here into 2 pieces. That does not work. And sorry if I'm sweating. It's like 95 degrees in my room right now. Okay, but I don't have one of these lovely smart boards at home. Right? So again, that's kind of that middle part. That's step 2. How does each box or piece change? Each bigger box became 2 smaller boxes. And you can see that here. The big box became 2 smaller boxes. So did this one. So did this one. I know this one's a little harder to see. I'll do just one full red line just to see if that sticks out a little more. Again, my one blue box got cut into 2 smaller boxes. Again, it didn't really change how much is still, right? It's not how much more I ate or need or whatever. It's just calling it something different. My one blue piece is now 2 smaller pieces. And my 4 original pieces, before I put those red dotted lines in there, there's now 8 of those. And there's a kind of a relationship here. This middle part might seem kind of weird at first, but then when you kind of see it, you'll be like, oh, right? The 1 got multiplied by 2, and the 4 got multiplied by 2. Okay? Any number above itself is just the number 1. It's kind of a rule we learned just in regular math. Like I can pick a big number, right? Like 632 times 1. It equals 632. Right? Any number times 1 just stays the same. So that's kind of why we can call these are equivalent. Again, I'll put the word equivalent down here. It has, or almost has, the word equal right in it. Kind of a different variation of that. Equi. Okay? Meaning equal to. So again, 1/4 and 2/8 are really the same amount. Kids always get tricked by that because you say, well, wait, whoa, now I get 2 pieces. Before I only got 1. Yeah, but that one piece was bigger. You can do the same thing if you're thinking about something like pizza. Cut a draw out over here. right? Be another example. This person got half of this giant pizza, right? This person got 2/8 of a tiny pizza. Which person got more pizza? And so that's another thing, right? That's a much bigger pizza, so it doesn't count. Okay, even though this person got one piece, this person got two, those two pieces are tiny. So that's another part of this, right? The boxes themselves have to be, I know my artwork isn't the best, but if I could actually make a straight line and that wasn't as crooked, right, all 5 of those boxes would be equal. Again, I would chop them up all equally the same way and that kind of thing. So that's also kind of something to keep in mind. You have to have kind of the same size pieces, which is why you can't just cut some of the pieces in half, but not all of them. Okay, those are just, again, rules of math. Right? I cut this in half, I cut this in half. Each bigger box became 2 smaller boxes. Then this is kind of the equation we end up with. So again, I'm going to go back to my beginning again and start here. What fraction did we start with? You have to use your imagination a bit and pretend like those red lines aren't there. Again, what was our original fraction? What was it before we tried to change things? And you can see there's 2 blue ones. Total 1, 2, 3, 4, 5, 2/5. Okay, and then again, I'm thinking, well, how did each box change? That's time I went up and down. Here I went side to side. But again, each box still changed the same. You should be able to pick any of the boxes and figure it out. Right? How many smaller boxes are here? 1, 2, 3, 4. Right? Each box changed by 4. Again, you notice the amount of blue wouldn't change. If I erase that red line, the amount of blue is the same. It's just 2 really big strips of whatever, 2 really big pieces of whatever it is. All I'm doing is taking those 2 big pieces and chopping them into smaller pieces. But I did it equally or evenly, right? This is that part that comes next. I changed each box by 4. I have to put that 4 on top and 4 on the bottom. That's to make it so it's one whole. I'm not changing how much candy I got or how many pieces of the candy bar or whatever. All I'm changing really is the size of them. You notice I got a whole bunch more pieces, but they were much, much, much tinier. So again, it might sound like you're getting more, but you're really not. 1/4 and 2/8 in this picture were exactly the same because they were from the same size whole. Okay, the same size original candy bar. My pizza one that I know I erased because I'm going to need that space in a minute, that would be different because my 1/2 was of a much larger pizza. So half of that big pizza is a whole lot more than even a half of the tiny pizza. Well, really, that was 2/8 was a quarter of that tiny pizza, but you understand kind of what I mean. Okay, so it only really works if you're comparing them to the same size thing at the beginning. One big pizza and one little pizza throws that fractional comparison off. Okay, again, and then once I'm at that point, then the rest is just the math. You just do top times the top, bottom times the bottom. My 2 big blue pieces became 8 smaller blue pieces. My 5 big strips became 20 smaller strips. Again, you could go back through and you could count those if you don't believe me. Right? 1, 2, 3, 4, 5, 6, 7, 8 total. And again, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Again, another common mistake I saw yesterday. Some kids were counting the blue as the top and then the white as the bottom. It does not work that way. The blue is a section of the entire thing here. All these, at least the ones we're doing kind of this week, are less than 1. So there's no like improper fractions or mixed numbers for this part. Again, there will be kind of at a different point later. Okay, but again, I just want to show you this general. As long as 2 gets times by 4, 5 gets times by 4, they both changed the same way. Right? I can't do 2 times 3 and 5 times 4 and call that an equivalent fraction because they did not change the same way. Okay, again, here, both of them got multiplied by 2. They both doubled. Both got quadrupled or multiplied by 4. Each box got chopped into 4 smaller pieces. Okay, and then back to over here, same idea. Go back and think again, what was our original fraction before I changed anything? What was it kind of at the beginning? 1, 2, 3, 4, 5. Blue with one more is going to make 6. So I started with 5/6. Again, how did I chop up each piece or each box? Again, 1, 2, 3. See how my one blue box now became 3 smaller boxes? That's my middle number. I'm going to use it twice on the top and the bottom. And then what did I end up with? Now, instead of 5 big blue boxes, there are now 15 smaller boxes. Right? Instead of 6 bigger boxes to start, I multiply that by 3, and that's now out of 18. Again, both of my numbers change the same way. It's just a fancy pants way to multiply by 1, just looks way cooler. Right? Because again, everything got 4 times as big in terms of how many there are. But again, each piece is now 4 times smaller. Same thing here. There's 3 times as many pieces. You're like, woohoo, I get 15 pieces. But they're much, much smaller now. So it is still the same amount. And then I'll show you just sort of a quicker version of this, just without the pictures and just a quick jump through the math and manipulating it that way. And then let me show you this without the picture. Again, as you get better, you'll kind of down here stop needing the equation at all in the middle with the multiplication. You'll just be able to kind of think that part through. Okay, but for now, I want to kind of find those connections that I do have. So I actually probably went out of order. I'm actually going to start over here with this one. Right, where I already have 2/5. Again, just try to picture that. That's where we're starting with 2/5. We're going to multiply each part by 3. Not just the 2 by 3 or not just the 5 by 3, both of them. So my 2, that was supposed to be on green. My 2 pieces are both going to multiply by 3 to become 6. My 5 regular pieces are both going to multiply by 3 to become 15. So that's all that kind of happened there, right? We're just kind of keeping that progression going. Same thing with 3/4. Now I wanted to show you this one because this is kind of that thinking that's going to lead you to down here. Eventually, you're going to be able to skip kind of this part in the middle once you get good with the math part. I'm already kind of just thinking there, well, how do I get from 4 to 20? Or how many 4s do I need to make 20? Because that's my number I'm going to use twice in the middle. Again, use that bottom relationship. I don't know what this top number is yet because I don't know what the relationship is. Again, I have the bottom number and I have the other bottom number. I can make that connection, and I'll show you that more at the bottom. Right? 3/4 becomes how many 20? I'm thinking my 4 chart. 4, right? 8, 12, 16, 20. 5 was my groupings. That's kind of the number I'm using to multiply all the different parts. I also then have to multiply the top number by that same exact piece. I can't be like, yeah, I did this one by 4, but I want to pick a different number for the top. Nope, can't do it. It's not how this game works. Right? However, one number changes, the other one has to change the exact same way. That's going to be either multiplied, or next week we'll learn dividing, right? The same exact way. So 4 times 5 made 20. 3 times 5 makes 15. They are proportional to each other. And I'll kind of show you what I mean by that when we get back down to 1/2. It'll make a little more sense. 15/20 still means you got 3 out of every 4 pieces. Again, if I have 20 pieces, I say, okay, you get 3, I get 1. 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 At the end, you got 15 out of 20. I got 5 out of 20. It's that same relationship to each other. Again, it'll make a lot more sense with 1/2 when I get down to that one. And what I'm looking at kind of here, again, is how did the one number I know, how did that change? How did 6 turn to 12? Right? How do I change? What would I multiply 6 by to make it 12? I have to use that same relationship on 8. Again, that's pretty easy math facts. 6, 12, boom, 2. I multiplied this one by 2. I'm going to do the same thing down here. Okay, 8 times 2 is 16. Okay, again, both numbers multiplied by 2. I was kind of missing this piece. I had to figure out what's the relationship between the two parts that I do know, kind of like I did with 4 and 20. That's why I went on order and did this one first, because it was a little more easy to see. Okay, and then I'll show you something kind of with 1/2. Let me see if I can slide this one over. I didn't want to bring that other part, but that's okay. I can erase that. I can rebuild it. All right, so again, I'm just sort of thinking of 1/2. Kind of what would fit kind of in between these two. Right? If I double both parts, I can also get something like 2/4. 1/2 is a much easier one to picture in your mind. 1/2, I get 1, you get 1. Good deal. 2/4, I get 2, you get 2. Good deal. It's nice and fair. Okay, 1/2 is always a fair share. I get the same amount that you get. Okay? Again, if it's out of 8, it's now 4. Again, I could pick any random number. I could pick 20. I'm just going to skip around so I'm not just doubling the whole time. Oh, I was thinking ahead already in my mind. Right? If me and you are going to split $20, right, up here, I got 15, you got 5. That sounds like a good deal to me, my friend. No, it's not. Yeah, you're right. Guys, again, being good at math can be helpful for these kind of things. We got $20 to split. I get 10, you get 10. Fair deal. That's still 1/2. You can actually see it's the same thing, just you would chop those zeros off. Divide both by 10. We'll get to that next week. Again, you can think of any number on the top or the bottom. Right? I could pick a number like 24. Any number, really, even the odd numbers, can be split in half, but it's easier with the even numbers. And I get 12, you get 12. Okay, 30. Again, you get 15, I get 15. It's just 1 times 15, 2 times 15. 1 times 12, 2 times 12. 1 times 2, 2 times 2. 1 times 4, 2 times 4. 1 times 10, 2 times 10. Both numbers are changing the same way. And I could go all the way to like something crazy like 1,000. We each get 500. Still just half. If I took a candy bar and chopped it up into 1,000 tiny pieces, right, they'd be like little specks of chocolate dust. And you'd gather up 500 in your hand and shove it in your mouth. It's still just half a candy bar. Okay? Hopefully this is a little clearer, a little easier today to kind of figure out and to understand. And I will see you guys in the morning. I probably lost about 5 pounds sweating today.